Now this one is an easy question. So this says a steel ball of mass m falls from a height h onto the horizontal surface of massive mass. So let us say we have a horizontal slab and the mass of this slab is massive, that is infinite. This is very highly massive. So this is a massive surface. You can say massive slab. And there is a steel ball that is kept initially at height h. Now this falls with initial velocity u is equals to 0 and this collides with the slab. Let me read the question. This says, find the cumulative momentum that the ball imparts to the slab. The question says, what is the momentum imparted by the ball to the slab? So we have to find momentum, total momentum. So we have to find total momentum imparted to the slab, and this is by the steel ball. So by a steel ball. So what is the total momentum that has been imparted to the steel slab by this steel ball? And it also after numerous bounces. So there are large number of bounces. So what is happening? This ball collides, goes back to the height, some height, comes again collides. So this process goes on. And this question says, if every impact decreases the velocity of ball by eta times. So let us say this ball is coming, and when this comes here, this collides with velocity v1. So this is the colliding velocity. And when this rebounds back, the velocity becomes eta times lower, that is v1 by eta. Are you getting? So the bouncing velocity is v1 by eta. So if this is coming with velocity v1, it will rebound back with velocity v1 by eta. So I can make something a good diagram. So this velocity is v1, and when this rebounds back, the velocity will be v1 by eta. Are you getting? So let us try to find out the change in momentum of the ball after numerous impact. Initial velocity, if this is falling from height h, initial velocity when this is going to collide with this surface, everybody knows this velocity v1 will be under root 2gh. So v1 is under root 2gh. Now if this rebounds back, the velocity will be v1 by eta. So what is the change in momentum? So let us take upward direction as a positive direction, or you can take, if you want, you can take negative direction. So let us take upward direction as a positive direction. So the y direction, as usual, y direction is a positive direction. So my sign convention is this. So this direction I am taking as a positive. So what is the change in momentum? First time, delta p1 after collision 1, what is the momentum change? That is final momentum minus initial momentum. What is the final momentum? M v1 by eta minus what is the initial momentum? So m, and this is coming in the downward direction, the velocity is negative, so minus mv1. So what is the change in momentum if I take mv1 common? So I will have 1 by eta plus 1, so that is 1 plus 1 by eta. Are you getting? Now what will happen after the second collision? So this is the case after the first collision. Now in the second collision, this block is going up, this steel ball is going up by v1 by eta. It will reach to some height, maximum height, let us say here, and then start coming back again. And when it reaches here, it will have same velocity v1 by eta, because it has not lost energy. Kinetic energy has to be conserved. So when this just reaches at the surface, this will have a velocity v1 by eta. And when this collides and goes up again, velocity this time will be again eta times reduced. So we will have v1 by eta square. So before colliding, it has a velocity v1 by eta. After collision, it has a velocity v1 by eta square. So what is the momentum change? I can say delta p2. In the second collision, what is the momentum change? That is p final minus initial. P final is v1 by mv1 by eta square. And this is minus of minus, so plus mv1 by eta. Are you getting? So if I take mv1 by eta common, So if I take mb1 by eta common, what I will have? I will have 1 plus 1 by eta. Are you getting? So similarly, if you have for delta P3, delta P4, if you do the same thing, you will get a geometric sum. So what is the total momentum change? That is the total momentum change of ball. So this is the momentum change of ball. I can say what is the total momentum change of ball. So total momentum change of ball. So what is this value? So this value will be delta P1 plus delta P2 plus delta P3. Similarly, this process goes on. There is a large number of bounces. So let us keep this summation up to infinite. Let us plug the value of delta P1. So delta P1 I have already calculated. You can check your copy. This is mv1 1 plus 1 by eta. And the second you have mv1 by eta delta P2, that is mv1 by eta into 1 plus 1 by eta. And third term you can expect, what should you expect? This remains same and this divided by eta. So third term one can expect mv1 divided by eta square 1 plus 1 by eta. And this process goes on. So if you take mb1 common, let us say take mb1 common into 1 plus eta also common. So what you will have? You will have 1 plus 1 by eta plus 1 by eta square, and this process goes on. Now if you do summation, so mb1 1 minus 1 plus 1 by eta, and this is a sum of gp up to infinite, and each term is less than 1. So this is eta is 1.25, that is given in the question. So eta is basically greater than 1. So this means 1 by eta is less than 1. So I can use the geometric infinite GP summation, that is 1 by 1 minus eta. So 1 by 1 minus x, this is the value. Remember? So if you have this 1 plus x square up to infinity, sum of this GP is 1 by 1 minus x if x is less than 1. So I am using this result from sum of the GP. Everybody knows this result. So you will have mv1 eta plus 1 and divided by eta. So this eta goes out. So you will have 1 by eta minus 1. Eta goes out. So final value will have mv1 eta plus 1 divided by eta minus 1. So this is the change in momentum you will have of the ball. Of course, this is the same momentum that will be imparted to the slab with a negative sign, you can say. Are you getting? So if you see the magnitude of momentum that has been imparted to the slab, this will be the same momentum. So magnitude of momentum imparted to the slab, because Newton's third law, this momentum is destroyed of the ball, and we don't have to apply Newton's third law. This is the momentum that is destroyed of the ball. So where this momentum has gone? This momentum has basically transferred to the slab. So momentum transferred to slab, and this will be simply mv1, and v1 is nothing but under root 2gh that we have already derived, eta plus 1 and this divided by eta minus 1. So this is a fairly simple problem. Somebody can ask also, what is the total force that is exerted during this process? So F external, in that case, you will find F external is dP by dt. So you know dP you have already calculated, you have to calculate dt. So for that calculation of dt, what you will do is, you will see this is the first time this colliding and then going back. What is the time in this process? When this goes up, comes down, and then you find out the time for collision 2, time for collision 3. So what you have to do is, to finding delta t, you have to find t1 plus t2 plus t3, and this skip goes on, and then you have to divide by delta t. I will leave for you, you have to calculate t1 plus t2 plus t3. If the t1 is the time when during the time for collision 1, t2 is the time for collision 2, t3 is the time for collision 3. You find each time and you sum this one. I think this will also be a geometrical progression sum. Do up to infinite, and give me the answer. What is the maximum force that is this imparting? Are you getting? So you just find the answer, and if you get the answer, can you just tell me what is the answer you are getting? So after the class sometime you can tell me the answer is coming for this problem is this. I will be very happy. So you calculate the force exerted using the formula dp by dt. Dt you have to calculate using the maximum height is the h initial, and then you have to find second time what the t2 using b square minus u square is equals to 2as, or v is equals to u plus at. Using that kind of formula, kinematical equations, you can solve for t1, t2, t3. That is not a tough job. And then you have to apply ZP sum. I think this F externals comes out to be mg. I don't know exactly what the answer will be. So you try to find out the answer. If it's coming out mg, that's fine. I just suspecting, I'm just guessing this. This answer should come out to be mg. Okay, let us discuss the next problem.